Hello friends, welcome back to my channel ESHIKSHABYBRAJESH. You are looking at a hand-drawn contour map of the Indian subcontinent. The Himalaya crumbling in the north, the peninsula tapering into the ocean, the islands scattered like punctuation marks in the sea. This single image is our syllabus for today. The title of this masterclass is deliberate: Mastering Indian Physical Geography, Advanced Frameworks, Schematics, and Theoretical Integration for UPSC Mains. Read those words again: advanced frameworks, schematics, theoretical integration, because that is precisely what separates a candidate who scores 90 in GS paper 1 from one who scores 140. Let me be blunt about the modern examination. UPSC is no longer rewards the student who can merely name the Himalayan ranges. It rewards the student who can explain why the Himalaya is seismically active, connect that to the 2023 Josimath subsidence, and apply a theoretical model to the answer. Knowledge is the entry ticket. Frameworks, schematics, and integration are what actually win the marks. Over the next 15 slides, we will build exactly that capability. We will move from the philosophy of visual answering to structural geology, to geomorphic cycles, to the Ghats and islands, to the evolution of drainage, to the deep mechanics of the monsoon, to climatic regionalization, to agroecology, to geohazards, and finally to the grand integration of theory with the Indian context. So, sharpen your pencil, open a fresh page, and title it Physical Geography Means Framework. This is a class to attend, not a video to watch. Let us begin.
The visual language paradigm. Before we touch a single landform, I must change the way you write. Look at this slide. On the left, a dense, unreadable paragraph struck out with a red cross. On the right, a clean flow chart of the monsoon process ticked in green. This contrast is the single most important lesson of the entire masterclass. Here is the hard truth. An examiner evaluates roughly 30 answer scripts in an hour. That is 2 minutes per answer. If your answer is a wall of grey prose, the examiner's eyes glazes over and you get an average mark. If your answer contains a crisp flowchart, a label diagram, a comparison matrix, the eye locks on. Comprehension is instant and the marks climb. This is not a trick. It is respecting the examiner's time and cognitive load. The slide gives you three concrete techniques. First, the 15-second map. Practice rendering the outline of India and the world in under 15 seconds so that in the examination hall, a map becomes a reflex, not an effort. A map anchors your spatial understanding and signals authority. Second, schematics over sentences. Wherever you would write a paragraph describing a process, a geomorphic cycle, a monsoon mechanism, a landslide chain, replace it with a flow chart, a process response model, or a matrix. Show the casual arrows. Third, the integration technique. This is the master key. Optional paper aspirants know. No. Paper 1 is geographical theory and paper 2 is the Indian application. But even in general studies, the principle holds. Never discuss Indian geography without a theoretical backbone. Never describe the Ganga floods without invoking a system or process response model. Theory plus Indian example equals a topper's answer. Now, what is deep thinking in this? Ask yourself, why does a diagram score more than a paragraph that contains the same information? Because a diagram demonstrates synthesis. Anyone can memorize sentences. Only someone who truly understands the relationships can compress them into a schematic. The diagram is a proof of understanding. When you internalize this, you stop seeing diagrams as a decoration and start seeing them as your highest value answer real estate. Now, a recent trend in UPSC Mains we have seen over the last 5 years, examiners' reports and toppers' copies consistently show that high scoring geography answers are diagram rich. Questions increasingly use action verbs like illustrate, examine with suitable examples, and bring out, all of which invite visual structured responses rather than descriptive essays. So, for every physical geography answer, budget the first 30 seconds to sketch your diagram or table skeleton. Build the prose around the visuals, not the other way around. Structural control on landforms, theory to terrain. Now we enter real geomorphology and we open with a quotation you should memorize, Thornbury's dictum. Geologic structure is a dominant control factor in the evolution of landforms and is reflected in them. Write that on the first line of any landform answer and you have announced yourself as a serious student. What does structure mean here? It means the underlying geology, the rock type, its hardness, its arrangement, whether it is folded or faulted, ancient or young. And the slide gives us the two structural provinces of India side by side. On the left, the Himalayan formations, a high energy terrain born from the collision of the Indian Eurasian plates, characterized by extensive folding, thrust faulting, subduction, and rapid uplift of sedimentary and metamorphic rocks. The result, the world's highest peaks and deepest gorges. This is a landscape where endogenic forces, the internal tectonic engine, dominate. The land is being built faster than it can be worn out. On the right, the peninsular block, a stable, low energy terrain, an ancient craton of crystalline rocks, subjected to gentle block faulting over hundreds of millions of years. Here, the internal engine has gone quiet, and exogenic forces, weathering, erosion, running water, dominate patiently, carving planation surfaces and residual hills through multiple cycles of erosion. Notice the diagrams. The Himalayan block shows thrust faults and a subduction zone driving peaks toward upward. The peninsular block shows block faulting and long erosional planation. Here we have seen Himalayan block shows thrust faults and subduction zone driving peaks upward, and peninsular block shows block faulting and long erosional planation. Two structures, two utterly different terrains, exactly as Thornbury predicted. Now, here is the framework I want burned into your memory. The balance between endogenic and exogenic forces determines every landform on Earth. Where endogenic wins, you get high relief, youth, instability, the Himalaya, perfect example. And where exogenic wins, you get low relief, maturity, stability, like the peninsula. Now, apply this as a diagnostic tool. Give any Indian landform in the exam, first ask which force dominates here. That one question organizes your entire answer. This is what theory of terrain means. You carry a theoretical lens and read the landscape through it. We can see the previous year question of UPSC 2021. That was differentiate the causes of landslides in the Himalayan region and the Western Ghats region. The answer begins with the structural control, young folded strata, and seismicity in the Himalayas versus deep lateritic withering in the Ghats. Even in 2014 UPSC, question was bring out the association between global distribution of fold mountain and earthquakes and volcanoes. Again, structure controlling processes. Now, recent developments we can see in 2023. Joshima's subsidence is the perfect illustration of a structural control failing under human pressure. Fragile, thrust faulted Himalayan strata overloaded by construction. Cite it whenever you invoke Himalayan structural fragility. Clear? One more answer writing tip is open landform answer with Thornbury code. Then present a two-column structure versus terrain comparison exactly like this slide. Quote plus contrast equals instant authority. Get it? First Thornbury quote and then a two-column structure versus terrain comparison. Now, moving on to geomorphic cycles in the Indian context. This slide takes W.M. Davis' famous cycle of erosion and brilliantly plants it in Indian soil. Look at the descending curve from the jagged peak of youth on the left through the rolling hills of maturity down to the near flat plain of old age on the right. Davis proposed the landscape evolved through a life cycle driven by running water from the youth to old age, provided the region stays tectonically stable. Let me walk you through each stage as the slide maps it onto India. Youth, high potential energy, rapid uplift, active vertical erosion, deep V-shaped valleys and gorges. The Indian example, the Upper Himalaya, the Indus and Brahmaputra gorges, where rivers are still sowing downward into rising land. Obviously, there will be endogenetic forces in predominance and exogenetic forces in not that much in comparison to endogenetic forces. Then maturity. Lateral erosion takes over, gradient reduces, energy falls, valleys broaden, rivers begin to meander. The Indian example, the middle Gangetic floodplains, where the river swings in great loops across a wide fertile land plain. Old age. Now, minimal gradient, extensive flat areas, peneplains, reduced relief, the landscape worn nearly to base level. The Indian example, the peninsular peneplains and the extensive flat plateaus of southern India. Now read the key insight printed at the bottom because this is a pure gold. Landscape evolution is polyprocess. India's topography is a living museum of all three deviation stages simultaneously. Sit with that sentence. In a single country, at a single moment, you can stand in a youthful Himalayan gorge, a mature Gangetic meander, and a senile Deccan peneplain. India is a natural laboratory displaying the entire cycle of erosion at once. But I must make you critical thinker, not just a Davisian believer. Davis assumed uplift happens once, quickly then stops. A big flaw. In reality, in the Himalaya, uplift is continuous, so the cycle never completes. It is perpetually rejuvenated. This is why we see nick points, river terraces, and incised meanders, signatures of rejuvenation. So, the nick point, river terraces, and incised meander, they are the signatures of rejuvenation. The rival model of Penck's argued landforms reflect the ratio of uplift rate of erosion rate, a more dynamic view. In your mains answers, present Davis for structure, then critique him with the reality of ongoing Himalayan uplift, then mention Penck as the sophisticated alternative. That three-step move model, critique, and alternative is graduate level to expert level in one paragraph. We'll see in previous year questions linkages. UPSC optional and GS papers repeatedly probe landscape evolution and rejuvenation. Even a GS question on why the Himalayan rivers form deep gorges while peninsular rivers do not is answered through this youth versus old age rejuvenation versus graded profile framework. Recent trends, examiners increasingly favor concept plus Indian example questions. The ability to place Indian landforms onto a theoretical cycle, as this slide does, is exactly the integration they reward. Again, an answer writing tip for this: draw the descending youth maturity old age curve, label each stage with its Indian example, and add one arrow labeled rejuvenation curling back up in the Himalayan section. That single annotated curve can anchor an entire answer.
Now the peninsular flanks, western versus eastern Ghats. We now zoom into one of the most reliable comparison questions in Indian geography. The two great walls that flank the Deccan, the western and eastern Ghats. The slide gives us a clean 4-row comparison matrix. And I want you to absorb it as a matrix because that is exactly how you should reproduce it in the exam. Row 1, physiography. The Western Ghats are continuous, higher in elevation, and act as India's primary water divide. The Sahyadri is running unbroken from the Tapi to Kanyakumari, breached only at few passes like Thal, Bhor, and Pal Ghats. The Eastern Ghats, by contrast, are dissected, highly fragmented, chopped into detached hill ranges by the great rivers and generally lower. Then, row 2, coastal plain impact. Because the Western Ghats hug the coast tightly, the western coastal plain is narrow and uniform, with limited riverine interruption. The eastern Ghats sit further inland, so the eastern coastal plain is broader, a diverse landscape defined by numerous river systems and their deltas. Then moving on to row 3, drainage and landform. West flowing rivers like the Narmada and Tapi form estuaries, no extensive deltas, because they run through rift valleys and plunge quickly to the sea. But the east flowing giants, Mahanadi, Godavari, Krishna, Kaveri, build wide, fertile deltas on the eastern coast. This is the single most examined contrast. Estuaries in the west, deltas in the east. Then row 4, human ecology. In the west, urbanization and industrial pressure cause habitat loss and stress on fisheries. The Ghats biodiversity is under siege. In the east, the deltic fertility supports intensive agriculture, the rice bowls of the coastal Andhra and Kaveri deltas. Now let us think deeper than the matrix. Why are the Western Ghats continuous and higher? Because they are essentially a great fault scar, the edge of the Deccan block that has uplifted and tilted eastward during the rifting away of Madagascar and Seychelles. Why do east flowing rivers form deltas but west flowing rivers do not? Because the east flowing rivers have long, gentle, graded courses that deposit vast sediment, while the west flowing rivers are short, steep, and hemmed in rift valleys. So tidal action flushes their mouths into estuaries. See how one line of geological reasoning, a tilted faulted block, explain the physiography, the coastal plains, and drainage all at once. That is integrated thinking. In UPSC 2021, on differentiating Himalayan and Western Ghats, landslide draws directly on Ghats physiography and lateritic soil. The Western Ghats also anchor ecology questions. Recall the recurring debate over the Gadgil and Kasturi Rangan reports on ecologically sensitive areas. In recent developments, the July 2024 Wayanad landslides in the Western Ghats, a catastrophe driven by intense monsoon burst on deforested lateritic scarp slopes, is your most cited case study. Also mention the continuing tension over notifying Western Ghats ecologically sensitive areas across 6 states. Answer writing tip on that: reproduce the exact 4-parameter matrix, that is physiography, coastal plain, drainage, and human ecology, and add a small map showing the two ghats meeting at the Nilgiris. Matrix plus map is complete high scoring answer. Now, island topography, diagnostic genetic origins. We often neglect India's islands in preparation. A costly mistake, because islands are UPSC favorite way to test whether you understand genesis, the origin of a landform. This slide gives you a perfect diagnostic contrast. Two island groups, two completely different birth stories. On the left, Andaman and Nicobar Islands, tectonic and partly volcanic in origin. They are in fact the emergent peaks of a submarine mountain range, formed by the collision of Indian plate with the Burma plate, the same great arc that continues northward into Arakan Yoma and links ultimately to the Himalayan story. Because they are tectonic, they have relief, high peaks and valleys like Saddle Peak, the highest point, along with waterfalls and a network of distinct rivers such as the Kalpong. This is also why the Andaman Sea hosts Barren Island, India's only active volcano. Tectonic origin gives you height, drainage, and seismic volcanic activity. On the right, the Lakshadweep Islands, biogenic, that is coral in origin. These are formed by the patient work of coral polyps building reefs on the submerged volcanic tops of the Indian Ocean ridge, essentially atolls. Because they are coral, they are extremely low-lying, barely up to 5 meters above sea level, lacking distinct hills and valleys, and crucially, they lack significant rivers on or lakes. Because the terrain is porous, coral limestone, and the elevation is too low, rainwater simply percolates through. Biogenic origin gives you flat, porous, low, water scarce islands. Here is the analytical leap. From origin, you can deduce almost everything else: relief, drainage, soil, water availability, and vulnerability. Tectonic Andaman equals high relief, rivers, seismic risk. Coral Lakshadweep equals flat, porous, riverless, and critically acutely vulnerable to sea level rise and coral bleaching also. This is why Lakshadweep is a poster child for climatic change geography, acutely vulnerable to sea level rise and coral bleaching. So, a poster child for climate change geography. When a question gives you any landform, train yourself to ask first, what is its genetic origin? Everything flows from that. This diagnostic habit is the difference between describing landform and explaining it. In UPSC 2018, asked about coral reefs. How does the cryosphere affect global climate? And related environment questions repeatedly test coral formations, bleaching, and atolls. Island geography also feeds strategic questions on the Andaman Nicobar's role in the Indo-Pacific security and the necklace of diamonds doctrine. The Great Nicobar Island Mega Project. In recent development, you can connect with this. The Great Nicobar Island Mega Project, the Transshipment Port and Holistic Development Plan, has generated intense debate on the tribal rights, seismic risk, and ecological loss, cited for the development versus environment theme. For Lakshadweep, cite the 2024 tourism and infrastructure push and the perennial concern over coral bleaching during marine heat waves and rising seas. For this answer writing tip, 4 island questions always structured by origin, relief, drainage, vulnerability, and draw the two block diagrams, a tectonic peak versus a coral atoll, exactly as the slide shows.
Now, evolution of Indian drainage, the Himalayan origin. This is one of the most sophisticated slides in the deck and one of the most underprepared topics among aspirants, the evolution of the Himalayan drainage system. It is told here in 3 elegant steps. Master this and you can answer any question on why our northern rivers behave the way they do. Step 1, the Tethys Basin from the Cambrian to the Eocene. Before the Himalaya existed, there was the Tethys Sea, a vast sedimentary basin between the drifting Indian plate and the Eurasian plate. As the two plates converged, this basin began to close and the sediments began to rise. This is the geological stage on which the entire drama unfolds. Step 2, the Indo-Brahma or Shivalik river theory, from the Oligocene to the Pleistocene. This is the heart of the slide, proposed by the geologists E. H. Pascoe and M. S. Krishnan. They argued that in the past, a single mighty river, the Indo-Brahma or Shivalik river, flowed longitudinally along the entire length of the Himalayan foreland, from Assam in the east, across the whole Ganga plain, all the way to Punjab and into the Arabian Sea. One colossal river, gathering all the Himalayan glacial melt, running parallel to the mountains. Hold that picture. Step 3, dismemberment in the Pleistocene. Then came upheaval. Pleistocene tectonic movements, specifically the uplift of the Potwar Plateau in the northwest and the downthrusting at the Malda Gap in the east, broke this single giant river into 3 separate systems. The Indus system draining to the west, the Ganga system draining to the southeast, and the Brahmaputra system draining to the east. The mighty Indo-Brahma was dismembered into the 3 drainage systems we know today. That is why, if you look at a map, these 3 systems seem to radiate from the Himalayan front. They are the shattered fragments of one ancestral river. Now, why does UPSC value this theory so highly? Because it demonstrates that drainage is dynamic. Rivers are not permanent fixtures painted on the land. They are living systems that tectonics can capture, reverse, divide, and destroy. This is also the intellectual foundation for understanding river capture and the antecedent nature of the Indus and Brahmaputra. Now, be a critical scholar. The Indo-Brahma theory is elegant but debated. Some geologists question a single continuous channel. In your answer, present the theory confidently, credit Pascoe and Krishnan, then note it remains a hypothesis refined by later research. Showing you know a theory's status, not just its content, is doctoral level thinking. Previous year question, linkage. Questions on the evolution of Himalayan drainage or why Himalayan rivers are antecedent are answered directly from this 3-step model. It also underpins the 2016 type question on river course shifting and the perennial Kosi migration problem. No, let us connect it with recent developments. Connect this ancient dynamism to present concern, the possibility of tectonically or glacially triggered course changes, and the fragility of Himalayan rivers under glacial lake outburst floods, as demonstrated by the October 2023 South Lonak GLOF in Sikkim on the Tiesta. Answer writing tip: draw the 3 panels, Tethys Basin, the single Indo-Brahma river, and the dismembered 3 systems as a left to right sequence with arrows. A 3-stage flow diagram is far more powerful than 3 paragraphs. Drainage systems, Himalayan versus Peninsular. Having understood how the Himalayan drainage evolved, we now place it beside the Peninsular drainage in a direct comparison. the workhorse question of Indian geography. The slide organizes the contrast around three diagnostic features, and I want you to learn all. Feature 1, source and flow regime. Himalayan rivers are snow-fed, sustained by glaciers, and therefore perennial. They flow all year, even in the dry season, because the glaciers keep melting. Peninsular rivers rise on the plateau, the western Ghats being the source for the east flowing rivers, and are rain fed, entirely dependent on the monsoon, and therefore seasonal, exhibiting dramatic flow variation between the wet and dry seasons. Perennial versus seasonal, that is your first axis. Feature 2, geological nature and channel behavior. Himalayan rivers are antecedent. They existed before the mountains rose, which gives them high erosive power, deep gorges, and in the plains, restless shifting courses. Peninsular rivers are superimposed, and crucially, they have reached graded profiles. They have achieved equilibrium over vast geological time, so they have fixed courses, run along stable valleys, and show almost no meandering. Antecedent and youthful versus superimposed and graded, that is your second axis. Feature 3, basin size and structure. Himalayan rivers have massive basins. The Indus, Ganga, and Brahmaputra basins are among the largest in the world. Peninsular rivers have smaller, well-denned basins, separated by rigid geological divides. The Sahyadri-Aravalli axis being the Great Water Divide, you can see marked on the map, separating the small west-flowing basins from the large east-flowing ones. Look at the map on the right. The western Ghats acting as the water divide, the Mahanadi, Godavari, Krishna, and Kaveri fanning eastward to the Bay of Bengal. The whole peninsular drainage tilted toward the east. Let us extract the deeper principle. These three features are not independent facts to memorize. They all flow from one root cause, age and tectonic setting. The Himalayan system is young, glacier-fed, in a tectonically active zone, hence perennial, antecedent, and huge basin. The peninsular system is ancient, rain-fed, on a stable craton, hence seasonal, graded, and rigidly compartmentalized. Trace every difference back to that single root. Youth plus tectonics versus antiquity plus stability. And your answer acquires a spine. Then add the human consequence. Perennial Himalayan rivers enable canal irrigation and hydropower, but bring floods. Seasonal peninsular rivers force dependence on tanks, reservoirs, and groundwater, and breed interstate disputes. Physical cause, human consequence, always both. Previous year questions, UPSC 2019. Comment on the resource potentials of the long coastline of India and highlight the status of natural hazard preparedness in these areas. Drainage to coast questions build on this. And the recurring theme of Himalayan versus peninsular contrasts appears across GS1 in many forms, including the flood versus drought duality of Indian rivers. For connecting it with recent developments, the Ken-Betwa link, Foundation December 2024, connecting a Himalayan-fed Yamuna tributary system to the peninsular Betwa, the recurring Kaveri crisis during deficient monsoons 2023, and glacier melt concerns for the perennial Himalayan rivers under climate change, the very reason UPSC 2020 asked about Himalayan glacier melt and water resources. Again, for answer writing tip, present this as a 3-row table: source/regime, nature/channel, basin, plus a peninsular drainage map showing the Sahyadri-Aravalli water divide. Then close with one integrating sentence tracing all differences to age and tectonic setting. Now, moving on to the mechanism of the Indian monsoon. Beyond the thermal concept, we now arrive at the beating heart of Indian geography, the monsoon. And the subtitle of this slide is a challenge to you. Beyond the thermal concept, dynamic monsoon mechanisms. UPSC has moved past the schoolbook explanation, and so must you. The OLD classical explanation was purely thermal. Land heats up, low pressure forms, sea breeze rushes in on a giant scale. True, but hopelessly incomplete. It cannot explain the monsoon's sudden burst. its breaks, or its wild year-to-year variability. So the slide directs us to the three dynamic mechanisms that a serious aspirant must command. First, the shifting ITCZ, the Intertropical Convergence Zone. This is the planetary belt where the trade winds converge and air rises. In summer, it migrates northward over the Indian landmass, and this northward pull drags the moisture-laden southeast trade winds across the equator. Deflected by the Coriolis force, they become our southwest monsoon. So the monsoon is, in essence, the seasonal northward march of the global rain belt. When the ITCZ sits over the Ganga plain, we call it the monsoon trough. Second, Tibetan heating. The vast high Tibetan plateau acts as an elevated heat source in summer, a heat engine kilometers up in the atmosphere. This intense heating drives strong vertical air currents and, critically, establishes the tropical easterly jet streaming across peninsular India in the upper troposphere. The descending limb of this circulation reinforces the high pressure over the southern Indian Ocean, the Mascarene High, which is the very pump that pushes moist air toward India. Remove Tibet and you weaken the entire monsoon. Third, El Nino and ocean dipoles. Variations in sea surface temperatures. El Nino in the Pacific and the Indian Ocean, dipole in our own ocean, directly dictate the erratic, unpredictable nature of monsoon rainfall. El Nino tends to suppress the monsoon. A positive Indian Ocean dipole tends to enhance it and can even rescue the monsoon during an El Nino year, as it famously did in 2019. Note also the Somali jet marked on the map, the low-level cross-equatorial jet that funnels the Arabian Sea branch of the monsoon toward India's west coast. Here is the professor's exam hall question. Is the monsoon thermal, dynamic or oceanic? The mature answer, it is all three, operating at different atmospheric levels simultaneously. Surface thermal contrast, mid-tropospheric ITCZ migration, upper tropospheric jet streams, and ocean-atmosphere coupling. Never present one mechanism as the answer. Present the monsoon as a coupled ocean atmosphere land system. That single framing sentence moves you from a school answer to a research level answer and connect it forward, because the monsoon depends on so many coupled factors. Climate change, by altering sea surface temperatures, aerosol loading, and Tibetan snow cover, is making it more erratic. Variability, not just quantity, is the modern crisis. Previous year questions, UPSC 2023, the celebrated Purvaya question. Why is the southwest monsoon called Purvaya easterly in the Bhojpur region? How has this directional seasonal wind system influenced the cultural ethos of the region? This fuses the physical mechanism, the Bay of Bengal branch recurving westward up the Ganga plain, arriving in Bihar as an easterly wind, with folk culture. UPSC 2015. How far do you agree that the behavior of the Indian monsoon has been changing due to humanizing landscapes? UPSC 2017. Climate change and Himalayan and coastal states. Recent developments and trends. The 2023 El Nino driven deficit monsoon, around 94% of the long period average, followed by the La Nina supported bountiful monsoons of 2024 and 2025. A perfect back-to-back illustration of variability. IMD's shift to dynamical coupled ocean atmosphere ensemble, forecasting under the monsoon mission, and research on the westward shift of the monsoon low-level jet, producing fewer rainy days but more intense downpours. Coming on to answer writing tip, draw the monsoon schematic. India, the ITCZ trough, the Somali jet arrow feeding the Arabian Sea branch, the Bay of Bengal branch, and the Tibetan heat source with the tropical easterly jet. Then structure your answer. Classical thermal, then the three dynamic mechanisms, then implications for agriculture and disaster. Mechanism plus implication equals full marks. Stamps climatic regionalization. This slide introduces a named classification. L. Dudley stamps climatic regionalization of India, and I want you to understand why examiners love named schemes, because citing a scholar's framework instantly demonstrates that you have gone beyond the textbook. Stamp's great organizing idea is beautifully simple. He used the 18 degrees Celsius January isotherm as the primary dividing line of the country. An isotherm, remember, is a line joining places of equal temperature. This particular line, where the average January temperature is 18 degrees Celsius, cuts across India roughly along the Tropic of Cancer belt, and it splits the country into two great climatic realms. To the north of the line lies the subtropical or continental realm, a region of distinct seasons with genuinely cool winters, encompassing the Indo-Gangetic plains and the Himalayan alpine zones. This is where you get the sharp seasonal rhythm, hot summers, cold winters, that governs the wheat-based rabi agriculture of North India. To the south of the line lies the tropical monsoon realm, high annual temperatures above 24 degrees Celsius with minimal winter variation. The south simply does not experience a real winter. Its calendar is governed by rainfall, not temperature. Then Stamp refined further. These two primary zones are subdivided, based entirely on rainfall gradients, into 11 sub-regions creating specific microclimates. These range from the arid lowlands, receiving less than 25 centimeters of rain, think of western Rajasthan, all the way to the very heavy rainfall zones, receiving more than 200 centimeters, such as the Malabar coast and the northeast. So the logic is elegant. Temperature draws the primary line, rainfall draws the secondary lines. Deep thinking. Now, the critical scholars question, why did Stamp choose temperature first and rainfall second? And how does his scheme compare with the other great classification, Göppen's? Göppen used both temperature and rainfall with vegetation as an index, producing categories like AMW, RW, BHW, CWG, and so on. Stamp's system is arguably more intuitive for India because it foregrounds the monsoon's rainfall gradient, which is what actually governs Indian agriculture. In a mains answer, you should be able to name Stamp, name Köppen, name Trevartha, and briefly state each one's logic. Then argue which is most useful for a given purpose. Naming three classification schemes and comparing their utility is exactly the kind of scholarly range that separates a rank holder from an average candidate. Previous year question, linkage, climatic regionalization directly supports questions on India's climatic diversity, on why agriculture varies so sharply across regions, and on their delineation of drought prone and flood prone zones. It is the conceptual backbone for any question linking climate to cropping patterns. Recent developments, climate change is now shifting these classical climatic boundaries. The 18-degree isotherm and the rainfall belts are no longer stationary. Cite the expansion of semi-arid conditions, the northward creep of certain climatic zones, and the increasing frequency of extreme rainfall, even in traditionally dry regions. Mention the IMD's updated climatological normals, which reflect these shifting baselines. For answer writing tip, for climate classification answers, draw India with the 18-degree January isotherm as a bold dashed line splitting north from south. Then note the rainfall based subregions at the extremes. Name the scheme's author explicitly according to L. Dudley Stamp to signal scholarship. Now moving on to the synthesis, climate meets agroecology. Now the masterclass turns a corner from pure physical geography toward applied geography, where physical factors meet human activity. This slide is about how climate, soil, and topography fuse to create agroecological zones. Look at the interlocking gears in the diagram. That is the whole message. These factors do not act separately, they mesh together like machinery. At the center of the three interlocking gears sits the agroecological zone, and it is produced by the meshing of three drivers: climate, temperature and rainfall, soil properties, and topography. Change any one gear, and the whole agricultural outcome changes. But the slide draws a crucial distinction that UPSC has tested, so note it carefully. An agroclimatic region is based purely on rainfall and temperature, climate alone, to optimize crop suitability. India's Planning Commission famously divided the country into 15 agroclimatic zones on this basis. An agro-ecological zone is more holistic. It combines climate and soil type and hydrology into a single integrated unit. The Indian Council of Agricultural Research, through NBSS and LUP, mapped 20 agroecological regions on this fuller basis. So, agroclimatic equals climate only. Agroecological equals climate plus soil plus water. That distinction alone can be a 2-mark differentiator. Now the three real examples along the bottom, and these are pure application. The western dry region, arid climate plus sandy soil equals Badra and Gore cultivation. The environment permits only hardy, drought-resistant crops. The lower Gangetic plains, humid climate plus fertile alluvial soil equals intensive rice and jute cultivation. Abundance of water and rich silt supports water-hungry, high-value crops. The West Coast plains, hot, humid climate plus red and lateritic soil equals coconut, cashew and spices. The plantation economy of the Malabar coast written in soil and climate. Here is the synthesis one want you to perform. Notice how this single slide integrates everything from the previous 10 slides. The monsoon, slide 9, gives the rainfall, stamps classification. Slide IO gives the climatic zones. The Deccan Trap and river systems give the soils, and the physiography gives the topography. Agroecology is where all of physical geography converges to produce human livelihood. This is the integration technique from slide to made concrete. When UPSC asks why a particular crop grows in a particular region, do not give a one-word answer. Trace the causal chain: climate, soil, water, crop. That causal chain is the answer. Previous year questions, UPSC 2022. How can the mountain ecosystem be restored from the negative impact of development initiatives and tourism? Links topography to sustainable land use. UPSC 2021. How do the ocean currents and water masses differ in their impacts on marine life and the coastal environment? And many cropping pattern questions require exactly this climate, soil, crop reasoning. The distinction between agroclimatic and agroecological planning appears in questions on rational agricultural regionalization and cropping pattern reform. Recent developments cite the push for crop diversification away from water-intensive paddy in Punjab and Haryana toward millets and pulses better suited to their true agroecology, directly relevant after the International Year of Millets 2023 and India's Sri Anna Millet Mission. Also mention climate resilient agriculture and the redrawing of crop zones as climate change shifts the underlying climatic gears. Answer writing tip: use the causal chain format. Climate plus soil plus topography, agro-ecological zone. Characteristic crop, and give one example from each of a dry, a wet and a coastal region, exactly like this slide. Concrete regional examples lift an abstract answer into a scoring answer. Applied geomorphology, geohazards in India. This slide is a masterpiece for the modern exam because disaster management is the single most reliable overlap between GS paper 1 geography and GS paper 3. It takes one hazard, landslides, and shows how the same phenomenon has completely different causes in two different terrains. This is precisely the 2021 UPSC question rendered as a diagram. On the left, the Himalayan slope, landslides driven by structural vulnerability. The diagram labels the causes: tectonic faults, fragile sedimentary layers, and steep altitudinal gradients. The Himalaya, being a young, still rising, seismically active mountain built of weak, fractured strata, is inherently unstable. High seismic activity triggers massive structural failures. These are landslides born of the mountain's own geology and youth. Endogenic vulnerability on the right, the western Ghats slope. Landslides that are exogenetic and anthropogenic. Notice the different labels: intense rainfall saturation, a lateritic soil profile, deforestation, and infrastructure development like road cuts. Here the mountain is old and stable, so the trigger is not tectonics. Instead, extreme monsoonal cloudbursts saturate deep lateritic soils until they slump, and this is severely exacerbated by human pressures. Unchecked mining, deforestation, and roads and buildings cut into once stable slopes. So, the same word landslide conceals two entirely different causal stories. In the Himalaya, structural and seismic. In the Ghats, climatic and human. That contrast is the whole point. Let me give you the framework that makes you unbeatable on any hazard question. Every disaster is a product of hazard times vulnerability times exposure minus capacity. Apply it here. In the Himalaya, the hazard is intrinsic, tectonics. Reducing risk means reducing exposure, no reckless construction. Honor carrying capacity follows slope zonation. In the Ghats, the hazard is increasingly manufactured by humans. A reducing risk means removing the anthropogenic triggers. Stop the illegal mining, restore forest cover, regulate hill cutting. Same hazard, opposite policy prescriptions, because the causal drivers differ. This ability to move from cause to tailored solution is exactly what fetches marks in the disaster management sections of GS3. Previous year questions. This slide is the answer to UPSC 2021. Differentiate the causes of landslides in the Himalayan region and the Western Ghats region. Also, UPSC 2016. The frequency of urban floods due to high intensity rainfall is increasing over the years. Discuss the causes. And UPSC 2020 on cloudbursts and their disaster potential in the Indian subcontinent. Linking to the recent developments, the July 2024 Wayanad landslides in Kerala, the deadliest Western Ghats landslide in recent memory, driven by extreme rainfall on saturated deforested slopes, is your headline case study for the Ghats column. For the Himalayan column, cite the 2023 Joshimath subsidence and the recurring Himachal Pradesh monsoon devastation of 2023 and 2025. Mention the debate over declaring the Western Ghats ecologically sensitive areas following Wayanad. Answer writing tip. Reproduce this exact two slope comparison with cause labels on each, then close with the tailored way forward for each region. And always cite one live case study per column. Joshimath for the Himalaya, Wayanad for the Ghats. Current examples are worth double marks in disaster questions. Now we will discuss geographical federalism. This slide is where physical geography reaches all the way into the constitution. The concept of geographical federalism. It is an advanced integrative idea, and using this phrase in an answer immediately signals sophistication. Let me unpack it. The core concept stated on the slide is this: India's vast physical and cultural diversity necessitates a governance model that balances centrifugal forces, the diversifying, pulling apart tendencies of a hugely vast land against centripetal forces, the unifying, holding together tendencies. Geography itself creates the tension that federalism must manage. Physical diversity is not just scenery, it is a force acting on the polity. The slide gives three channels through which geography shapes governance. First, physiography dictates policy. Mountainous terrain demands entirely different developmental and infrastructural policies than the coastal plains. You cannot govern Ladakh the way you govern the Gangetic Plain. This is the geographical logic behind special provisions, hill area development, and differentiated administration. Second, coastal imperatives. The maritime climate and coastal geography require specific economic and environmental governance, distinct from the landlocked interior. Think fisheries, ports, coastal regulation, zones, cyclone preparedness, the blue economy. The coast is a different governance universe from the heartland. Third, isolation and identity. Rugged terrain and dense forests historically fostered tribal isolation, and this directly led to the modern reorganization of states to protect geographically distinct cultural identities. The creation of the northeastern states, the tribal majority states, the sixth schedule autonomous councils, all are geography crystallized into political administrative structure. Here is the profound integration: physical geography, cultural diversity, political structure. The mountains isolated communities. Isolation preserved distinct languages and cultures. Those distinct identities demanded political recognition, and the Constitution responded with asymmetric federalism. Article 371 provisions, the 5th and 6th schedules, union territories, 4 strategically or physiographically unique regions. So, when you write about Indian federalism in GS paper 2, you can now anchor it in physical geography, a move very few candidates make, and one that examiners find refreshing. Conversely, when you write about physical geography, you can extend it to governance. This two-way bridge between physical geography and polity is the highest form of the integration technique. Previous year questions, UPSC 2023. The Constitution of India is a living instrument with capabilities of enormous dynamism. Discuss symmetric, geography driven federalism is a superb illustration. UPSC 2021 questions on the demand for smaller states and on the rationale of state reorganization are answered richly through this geographical lens. GS1 itself asks about the factors behind the linguistic and cultural diversity of India. Again, geography is the root. Recent developments cite the 2019 reorganization of Jammu and Kashmir and the creation of the Ladakh Union Territory, a textbook case of physiography and strategic geography reshaping the federal map. Mention the ongoing demands for statehood and autonomous councils in various hill and tribal regions, and debates over the sixth schedule's extension. These make the geography meets federalism theme intensely current. Answer writing tip: introduce the phrase geographical federalism explicitly, then use the 3 channels physiography, coast, isolation as your 3 body paragraphs, each with a constitutional example. Linking a geography concept to specific constitutional provisions is a rare and rewarding move. Now, one of the most important concept, integrating paper 1 and paper 2. We are now near the summit, and this slide gives you the explicit formula for a top answer. Read the equation across the top. Paper 1, theory, model plus paper 2, Indian context, equals a 300 plus score analysis. This is the operating principle of the entire masterclass, made into an equation. The slide demonstrates the formula with 2 worked examples, and I want you to treat these as templates. You can adapt to any topic. Example 1, regional disparities. The paper 1. Theory is the core periphery model or growth pole theory. The idea that economic development concentrates at certain cores or growth poles and drains the surrounding periphery. The paper 2, Indian application. Explain the concentration of IT industries in urban hubs like Bengaluru and Hyderabad, which act as cores drawing migrants and investment, while surrounding smaller towns become resource peripheries, supplying labor and raw material, but capturing little of the value. So instead of merely saying it is concentrated in Bengaluru, you have explained it through a named theoretical model. That is the leap from description to analysis. Example 2, river interlinking and floods. The paper 1, theory is Morizawa's process response model and the systems approach. The idea that a river basin is an integrated system where a change in one part produces responses throughout. The paper 2, application, analyze the Ganga basin not as a mere river course but as an integrated system where upstream deforestation in the Himalaya directly causes million city flooding downstream in the plains. upstream cause, downstream effect, linked by systems logic. Suddenly, a flood is not an event, it is a system response. Internalize the deep structure here. Every strong mains answer has two layers: a theoretical skeleton, the model, the framework, the name concept, and an empirical body, the Indian facts, examples, current events. Weak candidates give only the body, facts without a frame. Slightly better candidates give only the skeleton, theory without grounding. Toppers fuse both. They name the model and ground it in a vivid Indian case and connect it to a current development. Practice this consciously. For every topic you revise, ask what is the theory here and what is the Indian example. Build a two-column note. Over months, you accumulate a library of theory plus example pairs that you can deploy instantly in the exam. This habit, more than any other, builds a 250 plus GS aggregate. Previous year questions: UPSC 2020, the interlinking of rivers can provide viable critically examine. Answered beautifully with Morisawa's systems approach. Regional disparity questions on migration, on balanced regional development, on the rural urban divide are elevated by co-periphery and growth pole theory. The examiner can always tell when a candidate is reasoning from a model versus merely listing facts. Recent developments for regional disparities cite the persistent divergence between southern and western growth engines and the eastern and central states, and the debate over the migration of talent to a few metros. For river systems, cite the Ken-Betwa link December 2024 and the 2023 Himalayan flood disasters where upstream fragility caused downstream catastrophe. A live Morisawa case study. Answer writing tip. Physically write the equation at the top of your rough sheet before answering any analytical geography question. Theory plus Indian context equals analysis. And force yourself to name at least one model. A named framework in the introduction sets the tone for the whole answer.
Now, we have reached the last slide of this class, the triad of landscape evolution. We have reached the final slide, and fittingly, it returns us to the intellectual foundation of everything we have studied. The classical trinity of geomorphology, drawn here as three great stone pillars holding up the temple of landscape understanding. This is the framework of structure, process, and stage. And if you remember nothing else, remember these pillars: structure, process, and stage. 11. Structure. The question it asks is, what is it made of? Always anchor your answers in the underlying geology, that is tectonics, lithology, and Gondwana versus Eurasian origins. Before you describe any landscape, ask what rock and what structure lie beneath it. We saw this on slide 3 with Thornbury. Pillar 2, the process. The question it asks is, what is acting upon it? Identify the active forces sculpting the land: monsoonal erosion, glacial melting, weathering, and increasingly anthropogenic pressure. We saw this in the geohazards of slide 12, where process and human pressure combine. Then comes the pillar 3, stage. The question it asks is, how old is it? Place the region in its evolutionary timeline: the youthful Himalaya versus the senile peninsular plateau. We saw this in the geomorphic cycle of slide 4. Structure, process, stage. What it is made of, what acts upon it, and how old it is. These three questions asked of any landform will generate a complete structured analytical answer. This is the Devasian Trinity, and it is your permanent thinking tool. And now, read the professor final note at the bottom of this slide because I want to leave you with it word for word. A geography answer without a map is a body without a skeleton. Anchor your answers in physical origins. Visualize spatial relationships and always connect the natural phenomena of human outcomes. Let those three commands be your discipline. 1. Always draw the map. It is the skeleton of the answer. 2. Always anchor in physical origins. That is the structure pillar. 3. Always connect the natural to the human. That is where marks and meaning live. Physical cause, human consequence, drawn on a map, framed by a theory. Let me give you the final synthesis of this entire masterclass. Every single slide we studied fits into the structure process stage triad. The plate tectonics, the peninsular shield were a structure. The monsoon erosion and landslides were processes. The geomorphic cycle and the youth versus senility contrast were a stage. And over all three, we layered the human dimensions, federalism, agriculture, disasters. So your revision strategy is simple. For every topic in Indian physical geography, file it mentally under structure, process, and stage, and then extend it to human outcome. Three pillars, one human roof. That is the architecture of topper's mind. Linking with the previous year questions, the structure, process, stage framework silently underlies almost every GS1 physical geography question of the last decade. From the 2014 fold mountains questions to the 2021 landslide questions to the 2020 glacier and cloudburst questions, candidates who answer through this triad consistently outscore those who answer through memorized description. Recent trends we can see, and then we will close it. The clear trend across recent UPSC mains papers is integration. Physical geography fused with disaster management, with agriculture, with environment, and with governance. The examiner rewards the candidate who refuses to treat geography as isolated facts and instead treats it as connected system linking the physical earth to human life. Master the triad, draw the map, integrate theory with the Indian context, and connect nature to society. And GS paper 1 will become one of your strongest scoring paper. That brings us to the end of the master class. Revise these 15 frameworks until they are reflexes. Practice the diagrams until they take 15 seconds and walk into the exam hall not as someone who has memorized geography, but as someone who understands it. So thank you very much. I am Brajesh Kumar Srivastava and this has been E Shiksha by Brajesh. Study well, think deeply, and I'll see you in the next class. Thank you.